Okay, going on with three-phase transformers, let's quickly compare three-phase transformers with single-phase transformers. Okay, single-phase transformers, we can only connect a single phase. As a result, we are limited to voltage as well as current. Okay, single phase transformers we can only use for domestic applications. Okay, in industry we can use three-phase transformers. Okay, now as we saw with the star and delta calculations with generators, we can have, depending on what we need, we can connect this into a delta configuration or a star configuration, depending on what we need, high current or high voltage, due to the line versus phase values. The problem with three-phase transformers is they are expensive, due to, instead of using a single transformer, we are combining three single transformers, and as a result they are much more expensive to use. Now the application of transformers. Application of transformers in three-phase is used in factories as well as for the national supply grid. We can have four different configurations when it comes to three-phase transformer. First type of configuration is my delta star configuration. Okay, delta versus star. Delta on the primary, star on the secondary. This is useful in converting a 3-line into a 4-line. Remember, the fourth line is my neutral that we can connect over there. This is used for domestic load purposes. Next option is my star delta configuration. Okay, star configuration to delta configuration. Okay, this is where I've got a 4-line input and I need to convert it to a 3-line input. Now this is usually used in my national supply grid in order to step up the voltage in order to connect it to the high voltage transmission lines. Next, we've got the delta-delta configuration. Delta on the primary, delta on the secondary. Okay, again, this is also used for national supply grid, typically in situations where I want to step up voltage or step down voltage at my substations. And then finally, again on the domestic side, okay, we have the star-star configuration, where we've got our transformers connected in such a way that I've got 4 lines in and 4 lines out. This will typically be used after my delta star configuration, because I've got 4 lines and 4 lines, and these are used for domestic, where we have our wiring into houses and factories. Now, because of the large amount of current flow that these transformers are dealing with, we need to consider cooling them. Okay, now in order to cool the transformer, we can use two methods. First method, which we're all familiar with, is the air cooling method. Basically, our transistor is placed in a situation whereby it can warm the air around it, that air escapes, and then as new air, which is cooler, is pulled into it, that will then decrease the temperature of the transformer. Second method of cooling is oil cooling. Now, with the oil cooling system, my whole transformer is submerged into a container which has an insulation oil. What happens is, as current flows, the coils and the transformer is going to increase in temperature, but that heat is then transferred to my oil. The oil is then moved through a radiator of sorts, which will then transfer the heat out into open air, and as the oil cools down, that cool air will be then moved back into the transformer's housing, which in turn will keep the transformer from overheating. There's a third one, which is an oil-air combination cooling, whereby we've got the exact same system, but instead of just a normal radiator exposed to air, this radiator over here is exposed to water, and that water will then more effectively cool down the oil.